Hey guys, it's Chris. Welcome back to another tutorial in the Tetris clone tutorial series. Sorry it's been a while. I know that I made some promises to continue on the series even though I was satisfied with what I've had. A lot of you have asked questions about how to add scoring, background music, how to adjust the keys to give a little bit more of the Tetris feel when you're moving the blocks back and forth and down, and how to increase the levels and how to hold pieces and things like that. So what I'm going to do is I'm going to go ahead and finish up the series, not with this one video here, obviously, but this first video here will start with keeping score. And then we'll do, just like before, we'll add one video at a time to make the tutorials easy to follow along with. And when we're done, we'll have a completed Tetris clone game that you can modify any way you like, and it should be something that you should be able to submit to any of the app stores that you can then sell or give away for free. As always, let's have some fun with this, and hope you guys learned something. If you have any questions, comment down below, and remember, please subscribe. So let's go ahead and get started. The first thing we'll do is make sure that we launch our project and make sure that everyone's still on the same page here. We've got the grid. We've got all the pieces in the grid. We've got our prefabs. We've got our Tetrominos in the resources folder. And that is actually not going to stay like this forever. I'm going to do a video where we're going to be optimizing our game. One of you has actually given me a great suggestion on how to optimize this part of the game. We're going to be optimizing most of the game to make some changes, to make it run a little better, and to basically minimize on our code base a little bit to make it easier to read and modify later if we have to. So just make sure everyone has this, our level scene, our game over scene. We've got a game script, a Tetromino script, the resources. If you don't have any of this, go ahead and follow the first few tutorials up until this point, and so that you can get caught up. So what we're going to do is we need to keep score, and the way we're going to do this is we're going to use Unity, the Unity UI, okay, the new Unity UI that came out with, I believe, 5. The same thing that we did for the game over scene. We're going to create a, we're going to go ahead and create a canvas. Okay, so that's just up here, game object, UI, and canvas. All right, so now that we've got a canvas created, okay, so we're not overly concerned with how the canvas is positioned relative to the grid, okay? Because when we're looking at our canvas, and I'm going to show you guys this, the one thing that we do want to do with our canvas is we want to change our UI scale mode from constant pixel size to scale with screen size, and then we're going to provide a reference resolution, and that reference resolution is basically going to set our resolution to that we're basically building our game in. And if we're building on a Mac for a screen layout, the safest way to go is 1920 by 1080, and that also holds true for when you're building games for the new Apple TV. You want to go with a 1920 by 1080 resolution to get that good aspect ratio that you're going to need for 1080p TV sets, okay? Because most of those are going to be 1080p. We're not going to do any scaling in 4K yet because honestly, there's not enough out there to support that. So let's go ahead and go with 1920 by 1080 as our reference resolution, okay? And we're going to leave reference pixels per unit at 100. Okay, and what's going to happen now is if we go to our game, we're going to set this to, let's go ahead and create, let's use a 16:9 ratio, and that's going to simulate a widescreen TV, and that's going to also play nicely with our 1920 by 1080 resolution, because that's a 16:9 resolution. Okay, so and I'm going to show you can't see the canvas yet because there's nothing on the canvas. But if we go into the canvas and let's go ahead and create a UI text object in our canvas. Okay. And we're going to use that text object to hold our score. And you see it got created down here. It's kind of small. Let's go ahead and double click on that so we can zoom in on this. So we're going to want to make that a little bigger. All right, so let's see here. We've got a width of 160 and a height of 30. So let's go ahead and do 400 in the width and maybe 100 in the height. Okay, and let's change this to the transform tool so that we can drag it around. And we're going to keep, let's put our score over on the right. Okay, so we'll put it right here. And then we're probably going to want to change the font size to this. And right now it's 14, which is actually very small. And so let's make it a little bigger. Okay. And that's probably good right there. And let's go ahead and set our, and I used 86 as a font size. Let's go ahead and set our text equal to 0. Oops. And let's do one more thing here. And what we'll do is we'll set our text to be right aligned, because at the right side of the screen, when we have our score, we want it to start moving to the left as it grows. So like, you know, if we go from 0 to 10, we want it to continue to go to the left. If this was left aligned, then we would end up with something like this, and it would just keep building towards the right, which just doesn't look right. So I'll start with 0. We will right align, and that'll be our score. So let's go ahead and do what's right, and let's name this text object here. Let's name this, let's call it score text. Okay, and this canvas, this is going to be our HUD canvas. Okay, so let's rename this to canvas HUD. And the reason that I'm doing this is because later you may want to add a pause menu to the scene, and it's good to have a separate canvas for the pause menu, just to make it easy to build another menu for you to use. Instead of enabling and disabling components that are on the canvas for your HUD, we're going to have a separate canvas to store the elements for our pause screen, which really shouldn't be much. Maybe a button that unpauses the game. Anyways, we're not doing that in this video. This video is all about keeping score. Okay. So now that we've got a text object to hold our score, we're going to need to somehow incorporate scorekeeping with our game. Oh, and one more thing. Like I said, this canvas here doesn't have anything to do with the size of our canvas in our scene. Doesn't have anything to do with how it's going to look in the game view. So if I go over to game view right now, you'll see that this score is exactly where it is in the canvas, because the canvas actually represents your screen. Okay, so which is 1920 by 1080, and what it does is it'll scale with our screen, so everything stays nice and justified wherever we have it. Okay, and I don't like the 0 being so far down. Let's bring it up a little bit. Okay, let's go back to game view, and yeah, okay, that looks a lot better. All right, so there's our score. Let's go ahead and work on what is going to be required in order for us to keep track of score. Now, with Tetris specifically, the way that scoring usually works is that you score when an individual piece lands. Okay, you get a specific score for that, whether it's clearing a line or not. It's just the piece lands, you get a score. And the next scoring is if you clear a line. You get a specific score for clearing one line. You get a specific score if you clear 2 lines. And then you also get a specific score if you clear 3 lines or 4 lines. And each time your score is going to be different based on how many lines you clear, right? So the best way to do this is to create some variables that'll hold our values for those scores. Okay, so what we're going to do is here where we've got some variables already defined, we're just going to go right here under where we define the grid. And we're going to go ahead and create 4 integers, and we'll make them public. So public int, and we'll call them score one line. And let's go ahead and set a score of 40 if you clear one line. And then score 2 line. If you clear 2 lines, let's go ahead and set the score to 100. And score 3 line. Let's go ahead and make that score 300. And if we score 4 line, which of course is called a Tetris, we're going to go ahead and set the score to 1200. All right. So what does all this mean? For now, nothing, because all we've done is we've created variables and we've assigned values to them. Our game still does not know anything about scoring. It doesn't know what we want to do with these numbers or these variables just yet. Right now, they're just variables with values that do nothing. What we have to do is we actually have to tell it, hey, we want to give our player some score because our player actually did something in the game that he should be rewarded for. So I'm just right now collapsing all of our methods to make the code a little easier to scroll through. What I'm going to do is I'm going to create a new method, and we're going to just call this, it's going to be a voided method because it's not returning anything. And all it's going to do is it's going to update the score. Okay. Okay, so in order to keep track of how many lines we've cleared, in this turn specifically, so let's say, and in this turn, I mean by we drop a piece, and that one piece is responsible for clearing 1 line, 2 lines, 3 lines, 4 lines. We need to keep track of how many lines have been cleared by that one piece, right? So what we're going to do is we're going to create a variable and make it private, and it's going to be an integer, and we'll call it number of rows this turn, and it's going to be initially set to 0. Okay. And where are we going to increment this? Where is this going to be incremented? Okay, where would be a good place for us to check in our code how many lines have been cleared this turn? Well, I can think of one place, and that is the isFullRowAt method. Okay, if there is a full row, right? If we iterated over the entire loop and didn't encounter any null positions, then we return true because we know we have a full row. That means that during this turn that we're still on, okay, we're going to increment the number of full rows this turn. We're going to increment it by 1. Okay, so since we found a full row, we're going to increment the full row variable. Right? So we've got a number of rows this turn being incremented. Okay? And so every time this method runs, and remember this method is being called, okay, until a full row isn't found. So once this returns false, it doesn't get called again. So this can be incremented over and over and over until there are no more full rows. So at every full row, this gets incremented by 1. And then what we need to do when we're checking our score, when we're trying to update our score, we just need to check to see what the value of this is. Okay, so the value of this can either be 1, 2, 3, or 4, okay, depending on how many lines were cleared, because we know that we can never clear more than 4 lines at a time, because the longest piece is the long piece, which is only 4 minos long. So the so if you build up your minos, your tetrominos, the most lines that you can ever clear at once are going to be 4, right? So 4 is the max. Okay, so the first thing that we're going to want to do in our update score method is we're going to check if number of rows this turn is greater than 0, because if the number of rows this turn is not greater than 0, then there's no point to even check any further to see if it's 1, 2, 3, or 4. Okay? But if it is greater than 0, then we do our checking. So we do if number of rows this turn equals 1, else if number of rows this turn equals 2, else if number of rows this turn equals 3, oops, and else if number of rows this turn equals 4. Okay. So there's our logic. All right. So now what we need is a way to set our score based on how many lines were cleared. And very, very important, after we get through all this logic, we know that we've updated our score. We know that we're done. So we want to reset number of rows this turn equal to 0. So that at the next turn, it doesn't increment from 4 into a higher number, because then we're in trouble, right? So we're going to keep number of rows this turn at 0 after we're done with all this, okay? And because I like methods, we're going to create a method for each case for clearing a row. So in case we want to do other special things when specific numbers of rows are cleared. So we're going to create 4 methods, okay? And just do void cleared public void cleared 1 line. Oops. And create another one, cleared 2 lines. And another, cleared 3 lines. And let's do another, cleared 4 lines. Okay. So then from here, we'll just call these methods. So cleared 1 line, cleared 2 lines, cleared 3 lines, cleared 4 lines. Okay. All right, so the update score part, the update score method is actually finished. But we need to make sure that we're actually calling our update score. So our update score is actually going to be called from a method that isn't running in this class yet, and that is the update method. We previously removed the update method from this class because all of the game movement, like the maneuvering around the Tetrominos and everything, was performed in the Tetromino class, so we had no need for the update method in the game class. But now we actually do need it because we have some game things that we need to do in the game class that require constant updates for at each frame rate. So we need our update method, and our update method is going to call update score. Okay, so far that's all we need it for. We may need it for other things later, but for now, it's just going to update our score. Okay, so it's going to call update score. So we can be done with that. And so now what we have is we've got cleared 1 line, 2 lines, 3 lines, and 4 lines. We want to update our score, right? But we haven't created a reference for our score yet. So we've got our canvas, right? Our HUD canvas, and we've got a text UI element in our canvas. And we've renamed it score and everything, but we don't have access to it because we haven't created a reference into this class for that specific game object. So the best thing to do here is to create a variable. And yep, of course, we need to import the Unity Engine UI namespace so that we can utilize the classes in that namespace. So for instance, here we're going to create a text type of game object, and we're going to call this HUD score, okay? And that's a text object. So with that, we can now, in our back in Unity, we can go to our game script game object here, which has our game script game object, or sorry, our game script game object, which holds our game script, now has a HUD score variable that we can assign this text object to. So we'll just drag that here, okay? Now we have a reference. Awesome, right? So now that we've come this far, we probably want to go back into Mono and create another variable. And this one, let's create a variable called current score, because we want to be able to update our score and not only make it what, and I guess we could get away with not doing it, not keeping a variable with the current score and just constantly converting back and forth from a string to an integer with our text object, but that's just not an elegant way to do it, I don't think. So here's what we're going to do. We're going to create a current score variable, and we're going to set it equal to 0 initially. And then every time we clear a line, okay, we're going to take our current score and we're going to update it by however many lines were cleared. So score 1 line. Remember, we created these variables up here. Score 1 line, 2 line, 3 line, 4 line. These are the score values for those lines, right? So now all we have to do is add to the current score what the score for the number of lines is, right? So we can just do this here. Current score plus equals score 2 line, current score plus equals score 3 line, and current score plus equals score 4 line. Okay, so now let's just go through the logic one more time here, right? We've created 4 variables, score 1 line, 2 line, 3 line, 4 line. We've assigned each variable a value, 40, 100, 300, and 1200. We've created a reference to our HUD score text object, and we've assigned it in Unity in the inspector. We've also created a private integer that is the number of rows this turn, which stores how many lines were cleared with the last piece that was dropped. We then created a reference variable for our current score, and that's going to be continuously incremented based on how many lines are cleared at the frame that we're currently at, right? We've then got our update method. We then, in our update method, call the update score method. The update score method, in turn, checks to see if the number of rows this turn is greater than 0. And if it is, then we check to see how many, just how many rows we cleared this turn. And then based on that, we call a method for either clearing 1, 2, 3, or 4 lines. And then in each of those methods, we set or we increment the current score by how many lines were cleared on that turn. Okay? So now that we've got a reference to our score, we can continuously update our UI with what the current score value is. And the best way to do that is, again, we are going to create another method. It's going to be a public void, and we'll call this update UI. Okay. And we've got to remember to call the update UI method from our update method. Okay. So the UI is going to be continuously updated at every frame, right? So, and what we want to do is we want to take this HUD score, right? HUD score, And we're going to grab the text property, okay? The text property, and we're going to just set that equal to the current score. We got to convert the integer to a string, okay? And that's a method that integers have in that this class has specifically in Unity. We can convert this integer into a string that can then be held in this game object, okay, in the property of that game object. So now what we're doing is we're just setting the text, the score text, which is this right here. This right here, we're going to set that equal to the string value of our current score. And our current score, again, is updated at every frame anytime a line is cleared. So with that, we should be able to go ahead and play our game. Okay, let's save. We should be able to go ahead and play our game and clear some lines, and let's see what happens to our score. Right now it's 0, and it should be. Okay. Let's go ahead and drop these. Now you guys will get to see how crappy I am at this game. All right, so here, we're going to clear one line, so our score should go up to 40. All right, there we go. Now, let's see if we can do something more tricky. See if we can get up to a 2-line clear. It's going to be kind of tricky. All right, now we're living dangerously. Okay, we're just going to jump right into a 3-line clear if we can. All we need is a long piece. You never get the long piece, even when you make the game yourself. They just never come. Still no long piece. Oh look, it's a square. Another green one. Oh, come on. Oh man, what? Where's my long piece? Hey, wait, let's clear 2 lines. So real quick, 2 lines, 100 points, so we should be at 140. There we go, 140. All right, now, let's keep building up to that long piece. This is gonna end up being a 4-line clear now. Just go ahead and throw that in there. There we go. And a 4-line clear will add 1,200 points, so we should be at 1,340 by the time we're done here. There we go. Okay, everything is working just like it should. Okay, we've got our scoring down. Now, there's plenty of ways you can go with this still. You can add some additional elements to the score, right? Such as maybe you're right now we're on level 0, and let's suppose that we clear 10 lines, and after we clear 10 lines, we move on to level 1. And since we're on level 1, the difficulties increase because the pieces are now moving faster. And since that's happening, we want to add some kind of multiplier to our score based on what level we're on, because we want to reflect that, hey, you know, player, you're doing good because you're now at level 1, so we want to reward you with more points if you're still in the game. Same thing with, like, you're all the way at level 9, you know, you really want to give a lot of points to someone if they can score a Tetris at level 9, right? Because at that point, you know, they're doing really, really good. And you don't want to just give them with 1,200 points at level 9 for clearing a Tetris, because that's a really, really big accomplishment, because level 9 is really hard. It gets really fast at level 9. I realize that we're not anywhere close to, getting to level 9 because, quite frankly, we have not implemented levels. We haven't implemented any multiplier scores for any of that stuff. We haven't even added the scoring for landing a piece without clearing a line. So how about we do that next, huh? Let's go ahead and add that in. And this is actually going to be a very, very simple add. So I'm going to stop the game real quick, and we're going to add in the ability to score when you take a piece, okay? And you drop it down, and you get a score for that. But we're going to throw in a twist. We're not going to give the same kind of score every time the piece lands. When the piece lands, we're going to check how long it took from the time the piece was instantiated to the time the piece actually landed, and then give a score based on how long it took the player to land that piece. So, in effect, what we're going to do is we're going to say, hey, if the player moved that piece down really fast and put it where it's supposed to go, we're going to give a higher score than if the player took his time trying to figure out where to put the piece. Because one way suggests that the player is just a super awesome player, so we should reward him with more points. And the other way suggests that the player is still kind of unsure of himself, so we'll give him some points, but not as many as we would give an experienced player, right? Okay, so how are we going to do this? First, know that the game does not know when a Tetromino piece has landed, actually. And but a Tetromino knows, okay, when it's landed. So the thing to do here is let's go into the Tetromino script, and the first thing we're going to do is we're going to create a variable, okay? And we're going to call this one, we're going to make it public, and it's going to be an integer, and we're going to call it, let's call it individual score. Because that is its individual score, it has nothing to do with lines or anything. And what we're going to set it to is, let's start at 100, okay? And 100 is going to represent what the score is going to be if the player immediately sets the piece down. We haven't implemented a way for the player to immediately set the piece down yet, but we can do that. Just not right this minute, but just know we start off at 100, and that with time, as time passes, we keep taking away from that individual score. So we're going to keep decrementing that individual score as time passes. And the way that we're going to do that is by creating another variable called, we'll call this one, we'll make it a float, and we'll call it individual, we'll call it we're going to call this individual score time, and we're going to set we're not going to set that at anything, right? Individual score time. Then in our update method, we're going to add in, actually before we do, let's create this method. We're going to create a method. I'm going to call this update individual score. Okay. And then in our update method, we're going to call update individual score. And then in our update individual score method, we're going to check if individual score time is less than 1. And basically what that's going to represent is that every 1 second that passes, we're going to want to decrement the score by, let's say 10, right? So if it's less than 1, then we're going to take individual score time, and we're going to increment it by time.delta time. Okay. Otherwise, if we are not less than 1, that means we are at or above 1 second. We're going to set individual score time back to 0. And we're going to set our individual score equal to mathf.max individual score minus 10 or 0. So why mathf.max? Because we use mathf.max to avoid our score dropping below 0 so that it's going to pick whatever's greater, right? So if our individual score is equal to 90, then between 90 and 0, 90 is going to be larger, 80 is going to be larger, 70, 60, 50, so on. If our individual score drops below 0, such as -10, then our score, the mathf.max method will actually return 0 because 0 is greater than -10, -20, -30, and so on. So we ensure that we always get back 0, and that's a nice, neat, clean way to get back 0. Now you could use that an if statement instead if you wanted. You could do if individual score is less than 0, then individual score equals 0. In my opinion, that's too much code, and this is just a cleaner way of writing it, right? So there's always more than one way to do something. So with this, we're subtracting the individual score. Okay, so we're decrementing 10 from individual score. So this is already happening now. Our individual score is changing as our piece is dropping. Okay, so now we want a way for this individual score to affect our actual game score when our piece lands, right? So where do we want to do this? We want to go into our check input, okay? And in our check input, you'll see here we've got our key down arrow, or time.time minus fall is greater than or equal to fall speed. This is where we set to spawn our next Tetromino when we know that our piece has touched the ground, right? So what we need to do in this very same else statement here is we need to set our game score. We need to increment our game score by our individual score. And we can't currently do this because actually the best way to do this is to actually take our score, our current score variable in our game class. Okay, we can take this current score and we can actually set that to a stat. So we'll make it public, and we'll set it. We'll create it as a static variable. Okay, so that way it'll be available from other classes. So we could actually just go into Tetromino now, and we could do game.current score plus equals individual score. Okay, simple enough, right? So now if we play this, every time our piece falls, we should be able to see that our score updates. So let's do one really quickly. Let's see how fast this went down. All right, so we got a 50 for that one. Let's see what we can get here. Let's see, we are up to 120, so we got a 70 on the last one. This one only gave us 40. Let's see if we can get one that gives us 0. So we let 10 seconds pass, and we just basically get no score for it whatsoever. There, nothing. We got no score. All right. So let's see here. We got 50. So as you can see, what you're mostly going to end up with is either 50, 60, or 70 or something like that, depending on how fast you go. Now, it appears that because we're constantly having to push the down arrow, that actually takes a lot of time for a piece to go down that way. So in a future video, I'm going to actually go over how to implement buttons that you could just hold down, and then the piece will just automatically drop for you at a faster speed than you could ever go if you were to just continuously push the button instead. All right. So now we've got a nice way to add score if the piece falls and drops, or if lines are cleared. So there are now multiple ways to score in this game. Okay. Let's see. So I think what I'm going to do is I'm going to stop the tutorial here. Because this should give you plenty of information and enough content to actually go ahead and implement your scoring system. Feel free to use different values for your scores. It'll it's your game. Do with it what you will. I'm just here to show you how to go about doing it. And like I said before, my way is certainly not the only way to do things. Feel free to try new and different ways. If you find something that's better or is just better for you to understand or makes more sense to you, then do that instead. I'm only here to guide you through the process. I'm not here to tell you how to do it. Okay? So again, hope you guys enjoyed this tutorial. Stay tuned for the next one, and I will see you guys soon.